Next, how to draw the FBD. So here we have step to draw the FBD. Okay, step number 1, sketch outline, shape. Step 2, show all the forces that act on body. Step number 3, label non-forces. Which means that we need to have, if we have cable, or we have spring, or we have weight, so we can show the magnitude and direction. And the last step, we can apply the equations of equilibrium and calculate for the unknown forces. So we can represent letters to represent the unknown forces. Remember, the first step is sketch the outline. Okay, number 2, show all the forces. And number 3, label the non-forces. And step 4, we can apply the equilibrium equation. For this figure, we can eliminate the support reaction at B, support reaction at D. Okay, and although we don't need to sketch this weight. Okay, now we need to choose what is the point of equilibrium here. So here, point A is in equilibrium. So you can sketch that. Okay, first, don't forget the axis. So this is axis X, this is axis Y. So how many forces we have here? So here we have tension in this cable, and then tension in this cable, and then tension in this cable. So first, you can sketch, we have DB. So we need to assume tension is in pull, throughout. So here we have tension in D. So next we have tension in A. So can we calculate what is the tension in A here? So tension in A here, because this weight, this cylinder is given the mass. So the mass can calculate the weight. So here you can calculate M is 40. 40 times 9.81. So you have the value for TA. So you can substitute TA. And then the rest you can calculate for TB and TD. So that is how the free body diagram can help us to determine the tension in cable. Now we want to study a particle in Coplanar System 2D. So this figure, okay, let's say a particle is subjected to coplanar force in the X and Y. So here we have X, we have Y. X and Y. So if we have forces here, so we have F1, we have here we have F2, and then F3, and then F4 here. So we need to resolve all the force into I and J components, because we want to substitute in summation Fx equal to 0, summation Fy is equal to 0. And the scalar equations of equilibrium require that the algebraic sum of the x and y components to equal to 0. So here you can resolve that. For F1, you need to resolve in X. Okay, and then you have resolve in the Fy. So here, if you have case like this, if your force is toward to this point, so you're going to have this direction. Like this. Okay, so you have the force become, like example F3, so here is your Fx and Fy here. Also for this F4, you're going to have in X and in Y. Okay, here is the scalar notation. So what we have, sense of the direction is equal to algebraic sign that correspond to the arrowhead direction of the component along each axis. And then for the unknown magnitude, we need to assume that arrowhead sense of the forces. And then since magnitude of the force is equal positive, if the scalar is negative, so it shows that the force is acting opposite to the direction. Next, let's solve example 3.1. So this is the example of 2D coplanar force system. So if the whole assembly is in equilibrium, then particle A is also in equilibrium. Then we need to determine what is the tension in the cable for a given weight of cylinder is 40 kg. So now we need to sketch what is the free body diagram. So everyone already know what is the method to sketch the free body diagram. So now, first, sketch the outline. So when we sketch the outline, we need to know what is the point of equilibrium. So now, point A is the equilibrium for this whole structure. So do we need to sketch the support action here? Do we need to sketch this cylinder? No, right? So first, we need to establish the axis. So for 2 coplanar means that we only 2 axis. So here we have X and we have Y. Then we need to sketch what is the tension in the cable. So this is cable TB. So here TB, T or F can be. Alright. So here we sketch the TB. So this is TB. And then what F? So we have here TD. So we need to sketch TD. So must remember the first thing we assume pull out. Everything is pull. Okay. And then we have weight here, right? So this is TA here. But TA here is represented by this weight. So weight is equal to mg. So you have 40 kg times 9.81. So you can have here W is equal to 392.4. Right? Next, okay. Next, what is the other info? We have, don't forget here, this is 30 degree. So you must write angle is 30 degree. Because after we establish the first step, then we can use the summation F is equal to 0. Then because of we have 2 axes here, coplanar force, so we can substitute. Okay, we can resolve the force in X is equal to 0. So what is the force? And then summation force Sy is equal to 0. And then what is the force? So must remember the Fx positive to X direction, Fy positive to the top direction. Next step is to apply the equilibrium equation. So why we can apply the equilibrium equation? Because particle A is in equilibrium, the net force at A is 0. So we can assume that FB plus FC plus FD is equal to 0 based on this figure FBD. So we can apply that all the summation force is equal to 0 in general. If in vector, so we can write that if the summation force equal to 0, so here we have component in X and in Y. So we can have that all components in X is equal to 0 and all component in Y is equal to 0. Or you can write in scalar form. Okay, you can write in scalar form. We don't have IJ, so we can have that summation F equal to 0 and summation Fy is equal to 0. So here, okay, so first we need to resolve all the forces in Fx positive. So we need to resolve all the force in X. So here, all the force in X here. Okay, so this is the X positive. Okay, so here we have FB. So FB we need to resolve in X component. What is the FB in F component? So we have FBX. So FBX is the FB cos 30. Right? Okay, here. So that is why it become like this. So when we have summation Fx equal to 0, so we have the FB cos 30 minus with this FD. So because this FD is negative direction. So that's why it's minus FD. So this is one equation. Okay, next, we need to resolve all the force in Y. So summation force Fy positive upward here. So whatever force come in opposite direction become negative. So we need to resolve this FB into Y component. So what is the FBY? So here we have FBY is equal to FB sine 30. So that is why here we have FBY summation Fy is equal to FB sine 30 minus 392.4 because this way is opposite direction to the positive. So we have two equation here. So we can solve. So solve here, we can solve the second equation here. This is the second equation. So summation FB sine 30 minus 392.4. So we can have FB is equal to 785 Newton. Alright, so this is positive, right? So the positive, our assumption is correct. Alright, next we can solve the FD. So we can use the first equation. So we can substitute FB here. Then we can solve what is the FD. So FD is become 680 Newton. So look at this. So this symbol means that negative. So means that when you got the negative, means that the assumption is correct. Let's solve example 3.2. So here another 2D coplanar force system. And then if the whole assembly is in equilibrium, then particle E is also in equilibrium. So we need to determine what is the tension in the cables DE. So this is DE, and then EA, this is EA, and then EB. So this is EB. For a given weight, cylinder is equal to 40 kg. So this is the weight of cylinder. Okay, so now the first step, we need to sketch the free body diagram. So before that, so what kinds of this structure? What is this? So this is cable or pulley, right? So what you can have here, what is the hints or what is the info can give us? So when you sketch the free body diagram, so we need to sketch the free body diagram. So this is the point of equilibrium. So here, so don't forget your axis. So this is your axis. Okay, this is axis X and this is axis Y. So you can have here the point E. So here you can have like this TB. So TB here is represented by this tension, right? TC. So means that TB is equal to this, TC is equal to this TB because it cable or pulley. So means that TB is equal to TC. So what is TC? TC is given by this cylinder weight. So TC is equal to W is equal to mg. So here you can have that TB is equal to 40 times 9.81. Right, then you can sketch another tension in cable. So you have here T, D, and you need to determine what is the TA here. Also, don't forget this angle. Right. Can you solve this? Next, after we sketch the free body diagram, then we can substitute into the equation of equilibrium. So first, we need to write what is the force in summation force Fx, and then we can write the summation force Fy. So first, we want to write the summation force in X. So summation force in F, so we need to consider X direction is positive. So this is the X positive. Okay, now we want to write what is the force in X. So here we have force in X, we have TED, and here we have the force TEB component X. So this is the TEB. So what is the component X? So we have here. So we have TBX. So second, we're going to have TBY. Right. So now we write summation force in X. So all force in X. So we have TED. TED is negative direction. So that is why here we have TED negative TED. And then we have plus with the this one TB. So TB here we have if you can write 40 times 9.81 is equal to 382.4. So here you have 392.4. So resolve into X component is cos 30. So is equal to 0 is become equation 1. So you can solve here. TED, negative TED plus 392.4 cos 30. So you can get TED is equal to 340. So if you get positive here, means that our direction is correct. Okay, next, we can solve that. We can express all the force in Fy position, Fy positive. So this is the Fy positive. Whatever force come opposite direction become negative. So here what we have in Fy. So Fy we have this one, by, tby. So tby, you can resolve the tb into y direction. So you have 392.4 sine 30. So what else? So we have ta. So ta is negative here. So that is why it become negative. Is equal to 0. This is second equation. So you can straightly solve TEA is equal to 196. So it is also in positive. So the assumption is correct. Got it? Now let's solve example 3.3. So here we have 2D coplanar force system, and then the whole assembly is in equilibrium. Then particles C and D are in equilibrium. So we need to determine the force in each cable, and weight of lamp is given 20 kg. So now, how many force do we have here? So here, we have 2 points of equilibrium, one at point C and one at point D. So, how many force we have here? So let's say here we have, this is 1, okay, this is a TE, and this is TF, and this is TC. Okay, and then this is at point D. Now at point C. At point C here is same lah. You have TC, and then this is TA, and this is TB. So how many forces? Unknown forces. So we have 1. This is 1. Okay, here this is 2. This is 3 and 4. So unknown forces we have 4 here. So TF. TF we can have the magnitude because this weight of lamp is given 20. So time 9.81. So you can calculate what is the weight for TF here. So now we need to draw 2 free body diagram. So first here we draw at point D to determine the TC and TE here. And then second, after we solve at point D here, then we can solve at point C here. Point C, we want to get what is the TB here and TE here. Okay, you got it? Okay, now we solve the tension at the point D, equilibrium at this point D. So at this point D, we want to solve what is the this one, FDE and FCD. So you want to call it TE also okay, this one TC also okay. So here we have the weight here, 20 times 9.1 is 196.2. So now you can write in the equilibrium equation. So first, this is number 1. We have summation Fy positive upward here is equal to, okay, now as usual, we need, if we have coplanar like this, so we need to resolve into X and Y here. So this is the 30 degree. So you can have that FDE sine 30. So now this is the weight. So minus 20 times 9.1, or you can write 196.2. So this is one equation. So here you can straightly solve to get what is the TE here. So TE here is equal to here 392 Newton. So it is positive, so means that the assumption direction is correct. Okay, and then next, the second one, you can resolve in summation Fx positive is equal to, so FDE we resolve into X direction. So we have FDE cos 30 minus FCD here. So is equal to 0. So we want to calculate what is the FCD. So we substitute the FDE here, then we can get FCD is equal to 340 Newton. Okay, next we want to move to this point. So this point C. This point C, so we need to sketch the free body diagram here. So first, we need to use this information of the data. So here, if you do like this, so this one is also 40 degree. So you can have that here. First, so this FCD, this one, so we need to get this one. So FCD has been calculated here. So FCD is 340. So now we want to get what is the FBC and what is the FAC here. So first, we need to substitute. We need to write in the equations of equilibrium summation Fx. So summation Fx positive to this direction. Right. So what we have here? So we have FCD. So FCD is equal to 340. And then we need to minus FB sin theta. So here we have sin theta because our angle is this side. So that is why when we want to resolve the FCD to this, we use the sin 45. And then here we can have that minus FAC. So FFC here, FAC, so we want to use this theta. So this theta, so we can use this scale. So this scale, so sin theta, so sin theta is equal to what? FAC, and no, we want to use cos theta. So cos theta here is, what is this cos? 3 over 5. So FAC, 3 over 5 here. So this is first equation. Okay, second, we can write that summation Fy positive. So we need to resolve positive Y, force in Y. So we can resolve that. Here we have FAC sine 45. So what is the sine theta here? So sine theta here is 4 over 5 here. And then minus this FBC. So this FBC, if you want to resolve into this one, it becomes cos 45. So because of it is opposite direction to the Y, so it becomes negative FB cos 45 degrees equal to 0. So this is the second equation. So here you can solve by using the calculator because you have two unknown here. So then when you have your calculator, then you can have that your FBC is equal to 275 Newton, and then you can have that FAC is equal to 343 Newton.